So my name is Karthik, and I'm responsible for the software development for Jacinto line of processors. And over the next few minutes, I'm going to be deep diving into Jacinto and just explaining you what are the products that are there, and then connect you with some of the demos, awesome demos that we have here and also in the rooms on the right-hand side. Okay, let's go and get started. So this is the similar slide that Artem showed in terms of what are the devices in the processors portfolio, and we're going to be zooming into the TDA, DRA, and a little bit of AM processors, covering the automotive, the gateway, as well as the industrial market segments. So let's start with the automotive space, right? So in order to understand where exactly TI is playing in the automotive space, let's understand this diagram a little bit. So on the automotive side, there is a lot of sensor integration that's happening, and Artem also touched upon it a little bit in terms of how prevalent these sensor integration is happening in all kinds of cars, all the way from the high-end to the low-end cars. And then there's also the level of autonomous, the levels of autonomous driving that you have. So the TDA family of processors is really enabling this piece, and as you can see, we've got like a whole set of devices which can solve problems all the way from a basic lane keep assist, a surround view, or even a park assist to highway autopilot type of a use case. And I'm going to just deep dive now into the next slides on some of the demos that we have, which are solving these problems, and you can see for yourself on how that is happening. The most important thing over here is that the TDA4, while these devices may actually seem like very different in terms of how they are really architected, but they come with a very good scalable solution. Like we've got a software compatibility in terms of you can develop, scale, and deploy your solutions seamlessly. You can just start on one device, and you can go across the family, port your software and your application seamlessly. These devices also come with a common IP set. So the peripherals, the IPs, and many of the things that are there on the device are also common, which helps you to optimize and reuse based on which way you scale up or down. And some of these devices are also pin compatible with each other, which really makes it even easier from a hardware point of view to go that scale up or scale down. And there are only 4 products listed over here on the slide, but these are just product families. But within each of these product families, you've got various devices at different cost points to suit your application needs. On the networking side, we've got the DRA line of products. These SoCs are essentially the DRA 829 and the DRA 821. They are mainly used in a few target markets like zonal gateways, central and domain gateways, and also some of these connected cars and software-defined vehicles. Similar to the TDA, these are also enabled by ready-to-use EVMs, scalable software, reference design for you to build applications on top, and supported by the standard SDK on the TI.com. On the, just zooming in a little bit on the industrial portfolio, we've got 2 families right now, the AM68 and the AM69 family, which are essentially categorized into 4 different market segments. One is called the general purpose, the analytics, the real-time control, and the networking. So on the, I would really encourage you to check out the scalable demo that's there on the room, right outside, where you can see these demos in action, especially on the analytics front, all the way from a Sitara MPU family to the Jacinto family, all running similar code at different performance levels. And as you can see from a TOPS enablement perspective, from talking about AI and analytics, you've got devices that scale up in the Jacinto family from 8 TOPS to 32 TOPS, solving many of the problems in machine vision and video surveillance and many others. On the real-time control, these devices are also used in many of the robot controls and drone markets, as well as the industrial transport control units, right? So these are also enabling the same, these family of devices. And similarly, we talked about networking as well. More importantly, I think when using devices such as Jacinto, it's also important to talk about PMICs. So we also provide integrated PMICs compatible solutions across these devices. The blue line indicates pin-to-pin compatibility, as you can scale from one device to the other. And the various PMIC options are also listed over here and usually supported by the reference designs. All right, let's zoom into the front camera megatrend, right? So we all know the cars of today are more cars of today are getting integrated with front camera, mainly because of regulations, which is the GSR regulations in Europe and many other regulations in other parts of the world. So front camera is becoming a mandatory feature. So when you talk about front camera, you could imagine an entry-level front camera or an NCAP certified front camera or a front camera integrated with other ADAS functionalities because you want to reduce the amount of ECUs on the system. The devices listed over here are suitable devices which are available now, which enable you to go into these markets. And I'm now going to connect you with a demo which we have enabled over here with our partner StradVision. So what did StradVision really do and how did they come up with this demonstration that you will check out later? So StradVision essentially took our Linux SDK, which is available for download on TI.com, which supports the deep learning, which uses the 8TOPS engine on the TDA4 ALO device, which has an inbuilt ISP in it and a whole bunch of display options. They took this Linux SDK and then they brought in their own models, which is essentially their own perception stack, which is what I think in the earlier slides we saw, the bring your own model concept. So they brought in their own model. The SDK provides you everything from an ISP connectivity to display to a Linux and deep learning and all of it in one package. So they brought in this, took advantage of the SoC architecture, and you'll see the demo in action over there, which can do all the things listed over here, right? Forward collision warning, AEB, steering assist, speed assist, lane departure warning, lane keep assist, all of this on a single SoC, which is called as a TDA4 ALO. Just to give you a flavor of what this SoC really looks like, right? I'm not going to really walk you through this thing, but just to give you a flavor, it has everything that you can imagine. I mean, it helps you optimize your BOM cost. It's got an MCU island. It's got multiple real-time controllers like R5F starting from the left to right. And then this one. And then you've got the Cortex A72 cores for your additional MIPS requirements. You've got a C7X MMA, which is for your deep learning. And then you've got the ISPs or the depth and DMPAC and VPAC is what we call it. Multimedia accelerators, security accelerators, whole bunch of connectivity options, so to speak, right? This is the flavor that you're going to see throughout the day in terms of all of the SoCs and all the product families are built on a common chassis such as this, which allows you to scale between all of the processor parts. Switching gears, we're going to talk about the domain controller, which is also another demo, which is enabled by another part, which is called TDA4 VLO. When you talk about what exactly a domain controller is, right? A domain controller is essentially, or an ADAS domain controller is essentially a 5V5R system, right? What does this mean? The 5V5R is 5 cameras, 5 radars with ultrasound, all of them running on a single device with deep learning capability and so on and so forth. So when you start designing a system such as this, these are the main use case needs. You need to have multiple cameras of various resolutions. You need to have, for example, an analytics engine for the NCAP certification. You need to have visualization, support for multiple displays, and of course, a whole bunch of peripherals. And it should be evident from the previous slide that all of these are enabled by the accelerators that are present on this device, which are listed on the column over here. So effectively, customers are right now using the TDA family of processors to integrate these multiple sensors, which are cameras, radars, ultrasonic, all of them driven by a single SoC and realizing the use case. So please do check out this demo, which is by one of our other partners, but it follows a very similar story, where you take our SDK, bring in your own stack on top of it. The difference between the previous demo and the previous example in this one is the addition of the GPU, which is also available on the device, supporting OpenGL and all the open standards to enable high-quality customer experience, especially in this case of a surround view or a park assist. The demo is over there on the right corner behind. The last one that I'm going to talk about is another domain controller design, which actually increases the complexity a little bit. This one is essentially having a 11V5R1L kind of a configuration with ultrasonic sensors. So really quick in terms of what this is. So this is essentially 11 cameras listed down over here, right? And then there is 5 radars on various positions in the car. And then there's also a LiDAR for driving. This demo has been enabled by yet another partner, Phantom AI, bringing in their own perception stack. You can see that demo also running there. The cool thing about this demo is also the fact that with all of this running, the overall headroom that is available on the SoC is super high, as in it uses very little resources from a compute perspective, leaving enough headroom for you to do other applications along with it. It's not like it's maxing out what you have. So do check out this demo. And I think that was my last slide. I will pass it on to Anshu, who will deep dive on the Sitara MPU product line.